we're continuing topic 3.2, implicit differentiation, and we're going to work through example 11. So in this example, it gives us a curve, and then it actually gives us the derivative, and it says we're supposed to show that this is in fact the derivative. So I'm going to go ahead and take the derivative. It looks like we have some product rules going on. So we've got the red is going to be the x, and the green is going to be the y squared. And then the second product rule, the red's going to be the x cubed, and the green is going to be the y. So I'm going to start by taking that derivative. So the derivative of the x is dx. Keep the green the way it is, y squared. Put a plus sign in there. Then keep the red the way it is, so x, and the derivative of the green would be 2y dy dx. Then I'm going to put a subtract, and then I'm going to use a parentheses actually because I don't want a sign mistake. And then we're going to take the derivative of the new red, which is 3x squared dx. And then I'm going to keep the green the way it is, y. And then we're going to add a plus sign. And then we're going to keep the red the way it is, x cubed. And the derivative of the green is dy dx. And then that is equal to the derivative of 6, which is 0. So now I'm going to rewrite it. At the same time I'm rewriting it, I'm going to get rid of the dx's, change those to 1s, and I'm going to distribute this negative sign. So I have y squared plus 2xy dy dx minus 3x squared y, because the dx is 1, minus, oops, there we go, minus x cubed dy dx equals 0. Now I'm going to box in purple anything that has a dy dx. And then in yellow, anything that doesn't have a dy dx. I'm going to move all my yellow to the right side of the equation. So when I move those to the right, I get 2xy dy dx minus x cubed dy dx equals, I am going to add the 3x squared plus y, or 3x squared y, and I'm going to subtract the y squared. And I'm doing that in that order on purpose because I'm looking at this numerator here, so I'm wanting to match that numerator. I'm going to factor out the dy dx, which then I get 2xy minus x cubed equals 3x squared y minus y squared. And then I'm going to divide by this. So we get dy dx equals 3x squared y minus y squared over 2xy minus x cubed. So I have proven that I have this right. In part B, we are supposed to find all points on the curve whose x coordinate is equal to 1. And write an equation for the tangent line to these points. So two things that I need for equation of tangent line would be a point and a slope. Well, I can get the slope from the dy dx, but I need a point and I need the y value. So 2 reasons I need the y value. So I'm going to use this right here, this original equation, and use that to solve for the y value. I'm going to put 1 in for the x. So I get 1y squared minus 1 cubed is 1, y equals 6. I don't really need the 1s. I'm noticing that I have a greatest common factor of y. Nope, no, I don't have. I want to move that. I want to get it equal to 0. Sorry, so I'm going to move the 6 over. So y squared minus y minus 6 equals 0. I am going to factor that. So 2 numbers that multiply to -6 and add to -1 would be -3 and 2. So I have y minus 3 times y plus 2 equals 0, which by zero product property means I end up with y equal to 3 and y equal to -2. So I actually have 2 y values. So I'm going to actually have 2 equations of tangent lines. So I'm going to start for putting in my slope for so I'm going to do dy dx, and I'm going to put in the point 1, 3. So that gives me 3 times 1 squared times 3 minus 3 squared over 2 times 1 times 3 minus 1 cubed. All right, so 1 squared is 1 times 3 would be 9 minus 9 over 2 times 1 times 3 would be 6 minus 1, which is going to be 0 over 5, or a slope of 0. So my tangent line would be y minus my y value, which is 3, equals my slope, which is 0, times x minus 1. I could leave it like that. However, what you would probably see on a test, since this is all 0 on the right side, is it would be y equals 3. All right, let's do the equation tangent line for the other one. So dy dx, I'm now going to plug in the point 1, and I'm going to use this negative 2. I'm going to plug that into my slope. So that would be 3 times 1 squared times negative 2 minus negative 2 squared over 2 times 1 times negative 2 minus 1 cubed. All right, so let's see, 1 squared is 1, times 3 times negative 2 would be negative 6. Negative 2 squared is 4. And then we've got 2 times 1 times negative 2 would be negative 4. And then 1 cubed would be 1. So it looks like I have negative 10 over negative 5, which equals 2. I'm going to do that equation of a tangent line. So y minus my y value was negative 2 equals my slope of 2 times x minus 1. And I could rearrange that. I'm going to just choose to leave it as is right now.